Hello everyone, myself Vishwesh from Welltech Multech, Dr. Rangarajan, Dr. Shakuntala Engineering College, pursuing final year at Electronics and Communication Engineering. I'm here to present my project title called Underwater Communication Solution using Acoustic Signals and RSI Tracking. This project was developed by three members, including Janathanan M, Sangit T, and myself Vishwesh Vevi, under the guidance of Mrs. Ajita Ma'am, ME, Assistant Professor. So, why our project is important? Well, the underwater communication solution using acoustic signals and RSI tracking addresses critical challenges in underwater communication, while traditional radio signals fails due to high attenuation loss. Why this is so important? So we provide the reliable communication by using the frequency division multiplexers we use to transmit multiple signals such as emergency response and propeller failure of the submarine. So real-time tracking system implementation using IoT, where we using RSI tracking based location, where it uses the signals of the transmitter and receiver and enhance the safety during underwater operation. And disaster prediction leverages AI models such as ANN and CNN that used to train the images of satellite images such as floods, cyclone. So this enables us to analyze the pattern and predict the potential threats such as various natural factor of tsunamis. And IoT integration provides a real-time data transmission to remote IoT platforms and enabling rapid responses and situation awareness. The main objectives of our project is to develop the reliable underwater communication system. So, by designing the system that ensures a stable and efficient communication with a depth of 8 meters by utilizing the frequency division multiplexing to transmit the multiple signals simultaneously. So, the multiple signals such as alert messages are emergency, propeller failure, and engine failure. So, this system works at 4 megahertz and enabling the real-time monitoring system. So integrating with the RSI based tracking to provide the accurate and real-time location monitoring, enhancing the safety and ensuring the precise underwater object tracking, and implementing the AI based disaster prediction by utilizing the neural networks such as ANN and CNN to analyze the underwater patterns and predict the potential threats such as cyclones, tsunamis, and underwater disturbance. Facilitate to IoT based remote tracking. Establish the connectivity with the IoT platform to transmit the real-time data and enabling the remote monitoring and rapid decision making for critical underwater environments. So this system improves the stability and efficiency by using the various technologies including PLL to maintain the stable signal quality within 8 meters even in the challenging underwater conditions. So let us see the hardware implementation of the project. So this one is a transmitter module and this one is a receiver module. So let us see what the components are in the hardware, the transmitter module. So this one is a transformer. So transformer that used to step up and step down the electrical signals, and we consist of FDM, which is uses frequency multiple division, which uses a multiple signal to transmit the signals, and we using the ESP886, which is IoT module, and we are using the ultrasonic sensor to determine the depth of the object. And this one is a Arduino Uno, which is act as a CPU and a memory of the project. And this one is a push button, which consists of 4 push buttons. So each one consists of different messages. So the first one is a propeller failure, and second one is an emergency, and third one is a engine failure, and fourth one is a some kind of help. And let us see to the and this one is a LED module, which is used to display the depth, and we are using the CNN and ANN module to deploy our satellite image to the system, and this LED display that used to determine the cyclone awareness and alert systems. And let us see the receiver module. So receiver module consists of a transformer, which is used to step down the electrical signals, and the same which is consist of an Arduino, and we are consisting of ESP86, which is a receiver of the IoT module, and the same RX, which is a water module. And let us see to the immersible thing, which is this is one is a transmitter module, which is submerged into the water, and this one is a receiver module. So the both are under the water, so which uses the electrical signals to transmit the information. Let's see the project demo of our project. So let's turn on the switch. So once the switch is turned on, so on the second, the ESP is connected to our mobile phone and laptop. So once the ESP is connected to our mobile, so we just see to the 4 buttons, which is consist of 4 messages, which is emergency, propeller failure, and engine failure, and submerge crack. So this message helps the transmitter to send the
message to the receiver to know the status of the ship. So once the button is pressed, so it will send the signals to the Arduino board, so which is the brain of our microcontroller. And once the message is transmitted to the round shaped conductivity module, so it transmit via water. So the electrical module will transmit the signals to the via water to the receiver end. So now the receiver end will come to the ESP8266. ESP8266 will send the message to the Arduino board. So now the Arduino board will connect it to the IoT device, and we can view to the monitor.
The receipt information can be viewed through this website called Adafruit. So this system integrates Adafruit IoT to enable the seamless real-time data transmission from underwater sensor to secure the cloud platform. The ADA Transport IO offers a easy-to-use interface that collects the visualize and analyze the sensor data, ensuring the efficient monitoring and management of underwater communication system. So let us see how it works. So the sensor collection. Underwater sensor gathers environmental parameters such as signal strength, RSSI, and pressure temperature. Data transmission to cloud, which helps to transmit the cloud using Adafruit MQT protocol for the reliable secured transmission. So the dashboard consists of the name of our project, and once the circuit is turned on, let us see how it works. So once the push button, which is consist of 4 emergency messages such as emergency, proper failure, and engine failure, and submerged rigs. So let us ensure that the live data is connected. So we are seeing that the data is disconnected. So let us turn it on. So as you see, the live data is connected via the emergency message is viewed. So let us go into the dashboard. As you see, when I press the push button, the message as shown with the time and the date. So we can ensure that the a person in the rig ship can send the message to the transmitter. So the 4 different messages were sent to the frequency division multiplexing, where the 4 images, 4 informations of emergency, engine failure, and proper failure are sent in the same frequency through the IoT monitoring system. Underwater environments are highly unpredictable with the potential of cyclones, tsunamis, and underwater disturbances that cause severe damage to the marine ecosystem and underwater structures and human life. So, need of early warnings. Traditional systems often rely on manual analysis or delay information, which can result in slow response during critical situations. Early detection and prediction of underwater disaster ensure the timely action and minimizing the damage or losses. So we are incorporating the AI models such as AN and CN in our system that can analyze the pattern in underwater data and predict the potential disaster, allowing the authorities to prevent the primitive measures well in advance. So the key benefits of system that prevents environmental and infrastructure damage and ensures the safety for divers and marine vessels and provides a real-time monitoring of better situation awareness. CNN and ANN are used in the various purpose for digital image processing, where CNN is a specialized type of neural network designed for the processing image and spatial data, and it applies a convolution layer that extracts the important features from the input image, where the ANN is ideally used for handling the structured data and predict the outcomes. The CNN model analyzes the underwater imagery and sensor data to predict the disasters such as cyclone and tsunamis by identifying the patterns and abnormalities. Using CNN and ANL in Anaconda provides an accurate real-time disaster prediction system that ensures safety and timely response for underwater environment. So make sure that the Anaconda navigator in the environment. So open the VS Code, then wait for the process to complete. Once the VS Code is launched, open the project. So let us run the command for the project. So terminal, let's click on your terminal. So first is a type of a programming language. So we are using the Python. So which is easy to train the models easy using Python language. And type the file name and now run command. So before checking the program, so check whether the bomb is placed in the right port. For that, click device manager and ensure the port in the right place. So now it's COM8. So let us change the COM7 to COM8. Minimize this tab. COM8. Now click the URL following. So once the page is visible, choose the file of our satellite images. So these are the satellite images. I have trained the model using AN and CN model. So let's go to the data set, test, and type of the disaster you're looking for. So let us click cycle. So once I open the file and upload this file to this website, so it takes few minutes to deliver the out. So we can see that the cyclone predicted is detected, and we can see it occurred in which season and the more affected area, and the pattern is resembled in which year, like 2022 and 2021. And it also gives symptoms and prevention. The symptoms of the cyclone is strong wind and heavy rainfall. So we can prevent by escalating the planning and building the cyclone resistant structures.
Applications. EM communication is used for real time communication between divers or between a diver and underwater equipment. It also predicts and prevents cyclones, tsunamis, and underwater disturbance using CNN and ANN models, which enables timely alerts to mitigate damage and protect human lives. Supports data exchange between autonomous underwater vehicles, remotely operated vehicles, and base station in shallow water. Monitors environmental changes like temperature, pressure to protect sensitive marine ecosystem, prevents damage to coral reefs and maintains ecological balance. Used in shallow water defense system for communication with unmanned vehicles, which is used for monitoring enemy submarines and also detecting underwater mines. Ensures safety of divers and equipment during underwater exploration and research. Used for short range data transfer between underwater sensors and surface platforms in shallow offshore drilling environments. As for the conclusion, our project Underwater Communication using acoustic signals and RSSI tracking enhances underwater safety by detecting cyclone patterns through CNN and ANN model. With Adafruit IoT integration, it enables remote monitoring and timely decision making. This system ensures accurate disaster prediction, faster response to threats, and protection of marine ecosystem and underwater infrastructure. Thank you.